Alright, for the next part of this review, we already worked through part A in the last video. In part B, we want to create an exponential equation which can be used to determine the amount of kryptonite that remains after T hours. So, just as a recap, we're working on the practice problem covering radioactive decay, and this was the packet that you got either today on October 6th or yesterday on October 5th. We know that the half-life of kryptonite is 20 days, and it takes 20 days so that means it takes 20 days for it to reach its half of its original size. And we started with 50 grams of kryptonite. So for this, when it says create an exponential equation, that is what our ultimate answer is going to be, and we need it to be true, valid for after T hours. So for this exponential equation, I already know that kryptonite follows a half-life rule. So that means it follows an exponential decay, where this is the size of kryptonite. And this is time. So we already know that from the first part of the problem. So I'll just use that information to create my equation. So the general form of a half-life equation is NT equals N0 times 1/2 to the T divided by H. My N0 is given in the last problem. It's 50. I still have 1/2. We know that T is our independent variable here. T is what we want to be able to plug into our equation. So T divided by, and then for H, our half-life, we know that the half-life of kryptonite is 20 days. So this is 20, because H equals 20 days. So let's look at the problem. We want this to be, time to be in hours. Okay, so my half-life is in days, and we want it to be in hours. So I have to do one more step. 1 day is equal to 24 hours. So 20 by 24, that gives me 480 hours in 1 day. So instead of writing it like this, I'm going to write my exponential model like this. The only thing that's changed is instead of having 20, I have 480 now, because we wanted it to be in hours. To do part C, you would just plot this function in your calculator, and I would just want a rough sketch of it. So it doesn't end up looking like this, but it's important that you know how to plot a function like this in your calculator. Any questions? Just post a comment if you have questions. Let's talk about part D. According to our model, how long will it take for 90% of the kryptonite to decay? So let me draw a picture of what we're talking about here. Say we have some initial blob of kryptonite. This is kryptonite. And we know that we start out at 50 grams. This is time. Okay, so as time goes on, our blob is getting smaller and smaller at an exponential rate. And we're interested in, let's pretend this blob is 90% smaller than that blob. So we want to know at what time does this occur, and also what size will it be. So we're in the same problem. We're going to use the same half-life equation. N0 is 50. I still have 1/2. T is unknown. H is 20 days. But I need to think about, what does NT equal? What is NT going to equal? We're interested in knowing how long it takes for it to decay to 90% of the original, 90% of it goes away. So it starts out at 50 grams. If I take off 90% of that, I multiply 50 by 1 minus 0.90, and I get 5. So 90% of it has gone away, and we're left with just 5 grams. That's the size of the kryptonite after some period of time. So for this, NT is going to be 5 grams. And we want to know how much time goes by whenever it goes from 50 all the way down to 5 grams. So whenever you have an equation like this and your unknown is in the exponent, we need to use the calculator. We learn tricks in the calculator that will give us the answer. Sometimes, most of the time, NSOLVE will work. Right now, I'm going to talk about graphing. Okay, so in order to solve this equation, what you do is you set f1 of x equal to one side, so f1 of x equals 5, and f2 of x is equal to the right hand side. So 50 times 1/2, and instead of writing t, I need to write x divided by 20. Okay, so f1 comes from this side, f2 comes from that side. I'll zoom in on my calculator while I do this. Okay, I need to go to, I'll start a new document. I will add graphs to it. My f1 of x is 5, so I just do 5 and push enter. My f2 is, you push the tab button to get to f2, so just push the tab button and you can enter in a second function. So I have 50 open parentheses 1/2 to the power of x minus 20, x divided by 20, and I plot that too. I can't see it in my window just yet, so just like I'm zooming out my camera, I'm going to zoom out of my graph. So menu, analyze graph, menu zoom out. So I just click until I can see the figure, the second function, and there it is right there. Okay, so my intersection point is somewhere over here. The steps that you follow to find the intersection point are menu, analyze graph, and intersection. And then we would click a little bit to the left and a little bit to the right. And there it is. Somebody didn't change the settings on their calculator, so we can't see, it's not in 3 decimal points. But our answer would be 66.4 hours. 66.4 hours.